Hi guys, welcome to another maths tutorial brought to you by Direct Tutoring. Today we're going to have a look at solving surds and we're going to see how to simplify and rationalize a denominator. So the questions that we're going to have a look at are these four here. Now to start with, the first two are fairly simple. However, C and D become a little bit more involved. Now all of these questions you could expect in the exam, or you could have a combination of them all. Now the easiest way to solve these is just to dive straight in and we'll have a look at an example. So if we go for the first question, which was solve the square root of 50. Now for surds, a surd is pretty much a number that you cannot square root without a calculator. You won't get a whole number. Now, when we simplify surds, you have a set of numbers that you have to try and incorporate into your answer. These numbers are like 16, because the square root of 16 will give you an exact value of 4. Square root of 4, which give you an exact value of 2, and so on. So we need to try and incorporate one of these numbers into the square root of 50. Now, to start with, you will do more or less a trial and error process. However, once you become good at it and you get more practice, you'll be able to work out what it is right away. So, underneath, we'll draw a large square root sign and we'll say, right, what two numbers will multiply to give you 50? Well, in this case, we'll try 25 times 2. Now, what you have to do is break these individually. Okay, so we'll do the square root of 25 times the square root of 2. Now, we can simplify the square root of 25 because we know that is 5, and the square root of 2 doesn't simplify, so that just stays as it is. And that is your final answer. So if we have a look at part B, which is slightly more involved but works on the same idea as question A. So we have the square root of 48 minus 3 root 3. Now, the trick here is this one is actually a lot easier than the previous one, because this value here, so the square root of 3 on this one, gives you a clue as to what number you have to incorporate into the 48, because you cannot add, subtract surds unless the number underneath the square root sign is the same. So this one we can leave as it is, whereas we have to turn our attention to the square root of 48. So, neglecting this one for now, we'll deal with the square root of 48. So, like before, big square root, and we say, right, we need two numbers that will multiply to give you 48. However, we've been given a clue. We need to incorporate the number 3. So, what two numbers will multiply to give you 48? One of them being 3. In that case, 16 times 3. So, same as the last time, we'll split them up. So we'll have the square root of 16 times the square root of 3. So, the square root of 16 is 4. And the root 3 stays as it is. So that is a simplified this surd, pretty much the same as part A. Now the only difference here is we then substitute this back in here. So rather than us having the square root of 48, we're going to replace that with 4 root 3 minus 3 root 3. Now, you only take the coefficients at the front away from each other or add them, but in this case this is take away. You don't do anything with the number underneath the square root sign. That remains constant. So 4 take away 3 is just 1. So your final answer in this case is root 3. Now, if we look at part C is a little bit more involved in that the question is asking us to rationalize the denominator. Now, a rational denominator is a whole number in the denominator of a fraction. So, because we can't get a whole number from the square root of 24, this isn't a rational number, it's an irrational number. So, what we have to do is, in order to rationalize the denominator, we have to know one of the laws of surds. And one of the laws is that a square root of, say, x times the exact square root of x, the square roots will disappear, so you're left with the value inside the square root sign. So if we keep that as a mental note when we come to answer this question. So, in order to get rid of the square root on 24, all we have to do is multiply the top and the bottom by the square root of 24. And that will give us a new equation of the square root of 3 times the square root of 24 divided by, now this rule is this law here. So this becomes 24 because the square roots will cancel on each other and we're just left with the value underneath the square root sign. Now, if we simplify the top line, when you multiply surds, you don't have to have them the same. It's just going to be 24 times 3, which will give you the square root of 72 divided by 24. Now, we have to simplify the square root of 72 because that is a surd. Now, we need two numbers that will multiply to give you 72. And there's a few combinations that you can use. However, we want to get the simplest number possible as the surd. So, let's try 36 times 2. Okay, because this 2 is going to be the smallest surd possible, and we're using one of the key numbers that can simplify completely. And that's all divided by 24. So if we split these up, we get the square root of 36 times the square root of 2 divided by 24. Now, square root of 36 is 6 root 2 divided by 24. Now we can simplify the 6 and the 24. So your final answer becomes root 2 divided by 4. So quite a lot of working, it's quite involved. However, the key thing to note is to rationalize the denominator, you must times it by the exact same thing, the exact same surd on the bottom. And that will cancel the square root signs. So moving on to the last question, question D. We were given a function. Now when you see f of x, that just means f is a function of x. And we have 3 root x. Now it's asking us to find the value of f of 12. So what that means is wherever we have an x, because the 12 has replaced the x here. So wherever I have an x, I'm just going to replace it with a 12. So in this case, we get 3 root 12. Now, it's asking us to simplify it as far as possible, so this is a surd. So we'll keep the 3 as it is, and we'll do a large square root. Now, two numbers that will multiply to give you 12. one of which should be able to square root properly. In this case, we can do 4 times 3. So if we split these up, keeping the 3 outside the bracket, we get the square root of 4 times the square root of 3. So then 3 still outside. Root 4 simplifies to 2, and the root 3 stays as it is. Now, the 3 is just going to multiply the coefficient at the front. It's not going to do anything inside the square root sign. So your final answer becomes 6 root 3. And that is your final answer. So, if we summarise, what we have is when you add and subtract surds, you must get the same number inside the surd. So for this, we had to incorporate 3 into the final answer so that we could take the coefficients away. To rationalise the denominator, what you have to do is to get rid of the square root sign, you simply multiply it, the surd, by itself, the exact same surd, and that will cancel the square root sign. And a rational denominator is a whole number on the denominator of a fraction. For these kind of questions, with the functions that incorporate surds, whatever the function the number is, you replace the x and simplify the surd the exact same way as the rest of the questions. Thanks for watching. Please don't forget to like and subscribe for more maths content, and we'll see you in the next video.